Let's talk about the hidden engine inside every piece of tech you own. The chip, your phone, laptop, car, even your fridge. They all rely on these tiny silicon brains. Chips are the reason our world is fast, smart, and connected. Without them, your smartphone would just be a phone, and your laptop a glorified typewriter. Every swipe, tap, or stream you do, that's a chip at work, processing millions of instructions in a blink. These chips let you edit 4K videos on your phone or play console-quality games on a laptop. The race to build the best chip is fierce. Giants like Intel, AMD, NVIDIA, and Apple are in a constant battle. Intel powered the PC revolution, AMD shook things up with Ryzen, NVIDIA dominates graphics and AI, and Apple's custom silicon changed the game for mobile and laptops. Every year, new chips make our devices faster and smarter, leaving last year's tech in the dust. This relentless innovation is why your next phone will make today's look ancient. In this deep dive, we'll decode what chips are, what they do, who makes them, and why this silicon arms race matters to you. We'll explore the brains, the builders, and the tools behind the tech. The story of chips is the story of modern life. Ready to see what makes your world tick? Let's dive in. When we say processor, we're really talking about a team of specialized brains on a single chip, an SoC, or system on a chip. Each part of this team has a job: the CPU, GPU, NPU, and sometimes a TPU. Think of it like building a house. You need a project manager, muscle, and specialists. The CPU is the project manager, handling a wide range of tasks and keeping everything running smoothly. The GPU is the muscle, perfect for graphics and video, doing thousands of simple jobs at once. The NPU is the AI expert, handling things like face unlock and photo enhancements. Some chips even have a TPU, a supercharged AI engine built for heavy-duty machine learning. Why all these parts? Efficiency. Each specialist does its job faster and with less power than a generalist could. This teamwork is why your phone is fast, your battery lasts, and your apps feel smooth. Modern chip design is all about dividing the work for maximum speed and efficiency. That's how a thin laptop today can outperform a desktop from just a few years ago. The right mix of brains makes all the difference. Let's break down each one. The CPU, Central Processing Unit, is the main brain of your device. It's the conductor, executing instructions from your apps and operating system. When you open an app or load a web page, the CPU springs into action. Modern CPUs have multiple cores, each handling different tasks at once, so your music can play while you browse the web. CPUs excel at complex, step-by-step tasks, making your device feel snappy and responsive, but they're not built for everything. Massive parallel jobs like graphics or AI can slow them down. That's why we have other specialists on the chip. Intel and AMD have battled for years to make the fastest CPUs, pushing each other to innovate. AMD's Ryzen chips brought more cores and better multitasking, forcing Intel to step up. In mobile, Apple's custom CPUs in their A-series and M-series chips set new standards for speed and efficiency. The CPU is still the heart of your device, but it's no longer working alone. Let's meet the rest of the team. The GPU, Graphics Processing Unit, is the powerhouse for visuals and parallel tasks. Imagine hundreds of workers painting a wall at once. That's how a GPU renders graphics, making games and videos smooth. NVIDIA's GeForce and AMD's Radeon GPUs set the standard for gaming and creative work. But GPUs aren't just for graphics, they're also great for AI, thanks to their parallel power. Enter the NPU, Neural Processing Unit, the AI specialist in your phone, handling tasks like face recognition and smart photography. NPUs make your device smarter without draining your battery. For the heaviest AI jobs, there's the TPU, Tensor Processing Unit, Google's custom chip for massive AI workloads in data centers. TPUs power things like Google Search and Translate, training huge AI models at lightning speed. The rise of NPUs and TPUs shows how chips are evolving for an AI-driven world. Each specialist brings new capabilities to your device. The future of chips is all about smart teamwork. The chip market is a battleground led by three titans, Intel, AMD, and NVIDIA. Intel dominated PCs for decades with its core CPUs, known for reliability and speed. AMD, once the underdog, surged ahead with Ryzen, offering more cores and better multitasking at great prices. This rivalry drives innovation, making PCs faster and more affordable. Meanwhile, NVIDIA built an empire in graphics, with GeForce GPUs powering gaming and creative work. Their real breakthrough? Turning GPUs into AI engines, making NVIDIA the leader in the AI revolution. Today, NVIDIA's chips are the backbone of AI research and cloud computing. As Intel and AMD fight for CPU dominance, NVIDIA rules the AI frontier. The strategies of these giants will shape the future of tech. In mobile, the chip race is just as fierce, but efficiency is everything. Apple leads with its custom A-series and M-series chips, blending power and battery life like no one else. By designing both hardware and software, Apple's devices feel faster and smoother, even with less RAM or lower specs. The upcoming A20 Bionic and M6 chips will push performance even further. On Android, Qualcomm's Snapdragon chips power most flagship phones, with the Snapdragon 8 Gen 5 set to rival Apple's best. AI is the new battleground. NPUs in these chips handle on-device AI, from image generation to real-time translation. Samsung's Exynos and MediaTek's Dimensity chips are also closing the gap, bringing more competition to the high-end market. The 2026 mobile chip landscape will be defined by AI, graphics, and squeezing every drop of power from your battery. The race is on, and your next phone will be smarter than ever. Let's see how these chips are actually made. Chip designers like Apple, NVIDIA, and AMD are the architects. They create the blueprints, but most don't build the chips themselves. Instead, they rely on foundries, the builders. TSMC, the Taiwan semiconductor manufacturing company, is the world's top chip builder, making processors for Apple, NVIDIA, AMD, and more. Samsung is another major builder, manufacturing both its own chips and those for others like Qualcomm. These foundries compete to shrink transistors, measured in nanometers, making chips faster and more efficient. Intel is unique, designing and building its own chips, and now wants to manufacture for others too. This split, architects designing, builders manufacturing, lets each focus on what they do best. TSMC and Samsung perfect the art of making billions of tiny transistors work together. Without these builders, even the best chip designs would stay on paper. The partnership between architects and builders drives the pace of innovation. But there's one more key player, the toolmaker. The final piece of the puzzle, the toolmakers, companies that build the machines foundries use to make chips. The most important toolmaker is ASML, a Dutch company with a monopoly on EUV lithography machines. These machines use extreme ultraviolet light to etch impossibly tiny circuits onto silicon wafers. Without ASML's EUV machines, TSMC and Samsung couldn't make the latest, most advanced chips. Each EUV machine costs over $200 million and is a marvel of engineering. So, your phone's chip is the result of global teamwork. Architects design it, builders manufacture it, and toolmakers provide the tech to make it possible. The journey from blueprint to finished chip is a dance of innovation and precision. Next time you unlock your phone, remember, you're holding the product of a worldwide collaboration. Every part of the process, design, build, and tools is essential. That's what puts mind-blowing power in your pocket. Which part do you think matters most? The answer isn't simple, but the result is pure magic. See you next time.